So here we are. We're going to finish up Chapter 3 Toolbox, and we're on page 68 of the textbook in case you want to know. So we're talking about displaying detailed view of distributions. You can do that with the histogram and the frequency polygon, but sometimes you want to compare many distributions and you want an alternative option that does not sacrifice quality for quantity. So there are basically three options to do this. The Genome Box Plot, which is a box and whisker plot that shows 5 summary statistics along with the individual outliers. We've seen this before. This author says it displays far less information than a histogram. However, I disagree with that. But anyway, you can do it. You can do a box plot in ggplot with both categorical and continuous variables. However, for a continuous variable, you'll need to set up the group aesthetic to define how the x variable is broken up into bins. Let's take a look at a couple of these plots. So this first one, we're doing it with clarity, which is a categorical variable, so we don't have to do anything fancy. And so here are our box plots, and we see the whiskers, and again the box plot shows a 50%. This is the median, the hard bar, and then 50%, 25 above and below, and then the whiskers go out to where it's estimated the end of the distribution is, and then it shows the outliers. So for each of these categorical clarity categories, 1, 2, 3, 4, 5, 6, 7, 8, it gives you a non-parametric view of the distribution, what the average is, where the distribution is heaviest here, the ends of the distribution theoretically, and then the outliers. So let's do a different example, but in this one we're going to draw box plots on caret. Now caret is a continuous variable. It's not categorical like clarity. So we have to tell it where the bins will be, and we do that by using cut width. And we're saying the bin will be 0.01. Okay, so otherwise it doesn't know how to cut up a continuous variable. You have to tell it. Okay, and when we do that, we get a similar looking plot, but we've restricted the bin width to 0.01. So you'll get 10 box plots between 1 and 2, and 10 box plots between 0 and 1. And again, it displays the same information as we saw previously. Okay, another way you can compare distributions is with the Genome Violin, and it's kind of like it's kind of a combination of a density plot and a box plot. So here we're going to apply the Genome Violin to the same variables, the same plots we just did, clarity, which is categorical, and caret, which is continuous. And so let's do clarity first. And where it's widest, that shows the most observations. So again, we're looking at the 8 clarity categories and comparing that to depth. And depth is the greatest right here, around 60 or 63. Okay, and it declines a little bit as clarity gets better. And then you can see the dark bar, the violin, this gets 50%. This is the median. And then the dark bar are the whiskers, analogous to the whiskers in the box plot. And then you have the remaining observations out at the end. So that's the categorical. Let's do it with caret, which is continuous. And again, to do the continuous, you have to tell it where to cut the bins. So we're saying every 0.1, I want a new violin plot. Every 0.1 caret. So we do that. And then again, you're going to have 10 in between 1 and 2 because you said cut it up at 0.1. And these display basically the same information, but this time against depth and caret. But we have artificially created bins at 0.01, so those are the distributions for that. Okay, you can also do Genome dot plot, but we don't have an example of that. So there's only 1 point for each observation, but again, we don't have an example of that. So we'll bypass that for the time being.